everyone. Today is another class of physics. This class is for grade 10. We still on the same block number 4. So today our presentation consists of 5 main parts and mainly focus on electricity and resistance, how to measure electricity and resistance. So we will start first with potential difference, and number 2, measuring electricity, how we could measure an electricity. Number 3 is the resistance, measuring resistance, and then we will say the relation or how changing resistance affect the current. If resistance is changing or changed, so what happened to the current? We will start with potential difference. So what's potential difference? As we can see here, the electrons moving around the circuit have some energy. So any electrons moving through the circuit, as we discussed in the last presentation or the last class, we said that the current moving from minus part to the positive part and moving through the circuit. So the electrons moving around the circuit or in the circuit have somewhat energy, which can be referred to as electrical energy. We can say this energy, it's a kind of electrical energy. So as electrons pass through the battery or any power supply, any other power supply, they are given potential energy. And as they move around the circuit, they transfer energy to various components in the circuit. So this energy is transferred to what all the components were inside this circuit. For example, when electrons moves through a lamp here, let us say this, for example, a lamp. When electrons are moving through the lamp or current moving through the circuit, so the lamp, they transfer some of their energy to the lamp. So there is some energy from electrons, they transfer to the lamp, so the lamp is lighting. Actually, the amount of energy that any unit of a charge or a column transfers between one point and another, so the number of joules per Columbus, and is called what? Potential difference. It's like what? Like a voltage. BD, shortcut of potential, P difference, potential difference. So what's potential difference? Potential difference is measured in what? In voltage. So it's what? Actually, it's like a voltage. It's a voltage, and is measured by volt. So it's often referred to as voltage. So it's actually it's what? It's a voltage, as we can see here in this figure. So we have one coulomb of charge, for example, carrying what? Energy in this one, and another one is here. So PD cross a lamp here from this point up to this point equal to what? Energy transferred to lamp by one coulomb of charge is calculated, or it's equal to what? Energy transferred to this lamp by one coulomb of charge. Okay, so now how we could use measure electricity, or what's the value of quantity of what? Electricity. Potential difference is measured using what? Voltmeter. It's using what? Voltmeter. Connect a voltmeter between 2 points, so you can what? Measure potential difference, which is like a voltage. It's a voltage. Is measured using by what? a device, a small device called voltmeter. When you want to measure the PD across a component, so then the voltmeter must be connected in parallel across what? That component. It must connected in parallel. We will say some circuit later, and we will show how voltmeter can be connected. Actually, we discussed this one in last class, but we will focus it again later. So to measure PD between or across a component, so the voltmeter must be connected in parallel, not in serial. Must be connected in parallel across that component, any component, resistance, lamp, any other component. So testing with voltmeter does what? Doesn't interfere with the circuit, provided the voltmeter has a high resistance. It has what? High resistance. So a voltmeter can be used to show how the potential difference varies in different parts of the circuit. So the voltage is not the same for all components in the circuit. Each component has a value of what? PD, or what? Of voltage. Depends on what? Depends how they are connected, depends the place of that component. So the value of PD is different from part to the part, or to another part. So in series circuit, you find different values of what? Of voltage, as we mentioned it before. So depending on what? On where you attach the voltmeter. So in series circuit, when components of circuit is connected in series, so different values of the voltage depending on what? You find different values of voltage depending on where you attach the voltmeter. But we have what here in circuit, in series circuit? We have the same current, as we mentioned it before, have the same current in series 1, different voltage or different PD. In parallel one, we have different current, but we have what? Same PD or same voltage. So we can assume that energy is only transferred when the current passes through what? Electrical component, such as lamp and motors. So the energy transfer to terminal energy or thermal energy as the current passes through copper connecting wire is very small indeed. Therefore, it's only possible to measure PD or voltage across a component. We will take some examples to actually it's easier to explain rather than this paragraph. So if we take this example here, as we can say here, this is a circuit. This is a circuit. It's connected in what? In parallel. It's connected in parallel. What we have here, we have a power supply here, two batteries connected together. This is the -1, this is the positive part, and this is the minus, and this is the positive. So the total, this one is connected to minus, this one is connected to positive. So this is what? Power supply. If you would like to measure the PD here on this power supply, so you need to connect it what? In this points, 2 points. You have to put a meter here. One part is connected here and another part is connected here. So the voltmeter here must show the value of what? 9 voltage of battery. So PD is equal to 9 voltage, equal to what? 9 joules transferred to each column. Anywhere in the circuit here, different places here, for example on this lamp here, if we can connect also voltmeter here, we put one point here and another point here, so we can get what? The voltage on this lamp as the same as in this one. So the voltmeter, it must give 6 volt here and 3 volt here. A meter is connected where? It's connected here, anywhere here in series what? Connection. So a meter here will display what the value of the current. This in series connection. In parallel connection, no, it's different. So now here in the circuit, the current is same, starting from here, moving like this. It get the same current here, same current. So you can put a meter here, anywhere here, any point here. So we'll get what the same value of 2 ampere. But different of what voltage. Voltage here 6 is not equal to voltage here. 3 is not equal to voltage here. If we have another component here, so the voltage is different. If we have parallel connection, voltage are same, but current is different. It depends on what? On the connection of all components of the circuit. So now we can conclude that we can measure the value of PD by using what? Voltmeter, as we discussed here. So now from this discussion here, there is a relation between 3 main things here. There is a strong relation between I passing through the circuit. For example, this is an I current, and what? Between the voltage V here, and between another thing which is what? Resistance. Current when moving here, for example, in this lamp, we will find what? Some resistance here, and from where it comes from this lamp, and the resistance comes from this lamp. And if we have resistance here, so there is an what? A resistance to the current in this circuit. So there is a relation between 3 main things here in the circuit, which they are I, current, voltage, and what? And resistance R. So now we will have a look at this. What is a resistance? A resistance, actually all components in electrical circuit, as we have discussed before, have what? A resistance to what? To current in them. Each component in the circuit have what? Resistance to current. The relation between voltage, current, and resistance is given by this equation. So voltage on any component in the circuit is equal to what? I passing through what? R. I times R. Voltage. So V is potential difference in voltage, in volt, which called V. I is the current in ampere. R is resistance in ohms. Voltage, ampere, resistance. So voltage is equal to what? I times R. Actually, it's easier to use what? This triangle to find the relation between 3 of them. If we are looking for phi is equal to what? The other 2 parts here. Put your hand here. So V is equal what? I times R. If you are looking for R is equal, put your hand here on R, height R. So R is equal what? Voltage over I. If you are looking for what? I is equal to voltage over R. It's easier. So resistance, in each component in the circuit there is what? A resistance. Resistance makes the relation between V and I. And V is equal to what? I times R. It's very important to be able to rearrange this equation when performing calculation. So it depends on, sometimes you have V and R, you need to find I. Sometimes you have I, R, you need to find V. It depends on. Just use, for easier, you need to use what? This triangle. And you find that R is equal to what? V over I. And this one, it calls what? Ohm's law. This is Ohm's law. It's very famous one. Okay. Now we will go we will go through some worked examples. Example number 1. in example number 1 here, we have what? We have a heater element. Heater is connected to what? 230 volt what? Supply. Power supply equal to what? 230 voltage. So the current in the heater is what? 10 ampere. What we have here? We have current I is 10. I is equal to 10 ampere. V is equal to what? 230 V. So write down the formula in terms of R. We need to calculate what? Calculate the resistance of the heater. What's the resistance? As we said before, if current pass through any element, any component, so there is an inside what? Inside that element or that device there is an what? Resistance. So calculate the resistance of the heater. The heater, we need to write down the formula of R. R is equal to what? V over I. V is equal to 230 and I is equal to what? 10 ampere. 230 over 10 is equal to what? 23 ohm. 23 ohm. In example number 2, we have what? We have 6 volt supply is applied to what? 1000 resistance, 1000 ohm resistance. So what we have here? We have V and we have what? R. So we need what? What will be the current? We need to find what? I. I is equal to what? V over I. I is equal to V over R. So V is equal to 6 and R or the resistance is equal to 1000. So I is equal to what? 0.006 ampere. Or 0.006 ampere. Small amount of current. Okay. Now we will see how we could measure what? Resistance in the circuit. It's not by calculation. We need to use what? Voltmeter and ammeter, and then we will find the value of R inside the circuit. So the resistance of any component here in this circuit, for example this lamp or any component in the circuit, there is an what? R inside this component. Heater, resistance, lamp, any component, there is what? There is a value of R. We need to measure a resistance. So it could be found using what? This circuit. How? As we said, any component, lamp, resistor or whatever is placed what? In circuit with what? An ammeter to use to measure what? Current. There is an ammeter. We will use the meter to measure what? Current in that component. And voltmeter to measure what? The voltage or BD. So to take reading of those two things, current and voltage, as we say here, we need to turn what? Or to switch the circuit on. We need to switch the circuit on. So when we switch the circuit on, there is current start moving from here like this. Once the current is start moving, so there is a value of what? Of V here, value of V here, value of V here, and value of what? Inside resistance inside this, and the resistance inside the component here, and the resistance inside the component here. So now we need to use the voltmeter to measure what? Voltage, and we use a meter to measure what? Current. As we said before, we can connect, because the circuit is connected in series, we could connect a meter anywhere here in the circuit So we can get what? I. We can get what? I by using what? A meter. And I is same. Here, any point is same. The second step, we can use what? Voltmeter to find what? Voltage on that component. For example, as we said, lamp, resistor, heater, anything. So we will put the voltmeter and connect it as in this way here, in those 2 points here. So we have what? V. We have V by using voltmeter, and we have I measuring using what? A meter. So R is what? Is easy to find. R is equal to what? V over I. This is where by practical one, or by using voltmeter and ammeter, so we can use what? We can measure resistance inside the circuit itself. So just note that the reading or readings may change a little over first few seconds. Why? This is probably because of what? Because the component is heating up, and its resistance is changing. Resistance is changing because of what? Because of heating. So if this happens, what we will do? If this thing happens, you would have to decide whether to make the reading before the component have or has heated up very quickly, or what? You need to wait until the reading is stable, or stop what? Changing. So just note this one. Reading may change a little over what? First few seconds. It's keep changing. For example, if we measure voltage, if the voltage is 10, you will say like it's keep changing between 10, 10.5, 10.6, for example 9.5. It keep changing until stop changing. Why? Because what? Heating off or heating up, and its resistance is changing. So just you need to wait. You need to wait until the heating is stopped, or you need what? To take reading before component has heated up. Take the reading very quickly, and this one is equal to what? Measure to. It's using to measure voltage, or I, or R. So now we will go to say how changing resistance affect current. Resistance is changing, and how does it change or affect what? The current. So as we said before, there is a strong relation between resistance and what? Current. So changing the value of R is immediately changing what? The value of I. Because why? Because V is, for example, equal to I times R. So if we changing R here, it will, let us say, for example, I is equal to what? V over R. So any change in R immediately will change what? I. Immediately will change the current I. So the resistance, we can say that the resistance of most conductors becomes what? Higher in temperature of the conductor increases. So the temperature rises, the particles in conductor vibrate more and provide a greater resistance to the flow of electrons. So as we said, there's a strong relation between changing resistance and the value of I. So it's always affect what? The value of R is affected the value of I. Also, the value of V is also have some effect on what? I. So as we can see here, this is the relation between this is the current and this is what the voltage. This is the current and this is the voltage. Say the relation here, and the relation between current and BD here is like this. It depends on what? Depends on what we said in the last paragraph here. It depends on this one. So increasing value, increasing the graph, and changing the value of R is affected what? The value of current I. Okay, so for each for such resistors, any resistor here applies its Ohm's law, say page 259, and voltage is directly potential to the current. It is, and straight line is obtained, as we say here in this figure, is straight line. It depends on the relation between I and R. So this is all for today. If you have any question, please feel free to contact me, and we will see you inshallah in next week. Thanks for listening.